Okay, the next section of mole calculations has to do with finding the mass of a substance given the number of moles of that substance. So this formula is basically just this formula. Oops, not this formula. Okay, it's this formula, and the next one we're going to have is a manipulation of this one. But this one, you take the number of moles that will be given times the molar mass, which you can calculate as we did in section 3.1. So, starting out, number 38 says we have 0.331 moles of iron. Okay, so the molar mass of the iron is 55.85, and that's in grams per mole. So therefore, it's going to be the 0.331 moles times the 55.85 grams per mole to equal 18.5 grams of iron. Now, you're not required to put the iron, but I do count off if you do not put the units there of grams. Okay. For the next one, okay, now we have to recalculate the molar mass. So the molar mass of carbon dioxide, carbon, we have one of, and it is 12.01 to two significant figures. So that's 12.01. Oxygen, there's two of, times the 16 gives me 32. So that's a total of 44.01. And so I'm going to take the 0.034 moles times the 44.01, and I get 1.50 grams of CO2. Okay. And let me erase some of this stuff. The last one. Okay. So for the last one, I'll change colors here. Oops. Okay. That's new. Okay. All right. So the molar mass, I have potassium is 2 times the 39.10 to give me 78.2. The chromium is 1 times the 52, gives me 52. And oxygen, there are 4 of them, times the 16 gives me 64. So the molar mass of this compound is 366. Oh, wait a minute. Doing the wrong one. No. Yeah. It's 366. That does not seem right. K2. Oh, I'm sorry. Is 194. I did pre-calculate all these. I just don't know where I wrote it. Grams per mole. And then I take the 1.89 moles times the 194.02, and I get 300. That's where the 366 is. 366.7 grams of K2CrO4. Okay, so this is going to be a calculation that we're going to be using a lot, both in 1211 and in 1212. Okay, so. And this is an equation that is basically a manipulation of that one. So last time we had mass was the moles of a substance divided by the times the molar mass. But now we're trying to find the moles. So we take the mass divided by the molar mass to get the number of moles. Okay, and so you're going to have to keep straight in which way you go. Do I need to multiply by molar mass, or do I need to divide by molar mass? And if you're good with units, you can use the units to determine. In order to cancel out the grams, I have to divide. In order to cancel out the moles, like I did in the last problem, here, to cancel out the moles, I have to multiply. Okay, so if nothing else, you can use the units to determine this. Okay, so again, though, I need the molar mass of each one of these. Okay, and so the molar mass of arsenic is 74.92. I just pre-looked these up because it's hard to read on here, but I'm basically getting these from this right here. Okay, so I take the 2.57 grams divided by the 74.92, and I get 0.0343 moles of arsenic. Okay. For this next one, this is dinitrogen tetrahydride, just so you can practice the nomenclature, because it's a molecular compound. That's the name of it. Okay. The molar mass of this is nitrogen, there's 2 of them, times the 14.01 gives me 28.02. Hydrogen, there's 4 of them, times the 1.01 gives me 4.04. So the total for this is 32.06. So I take the 33.8 grams divided by 32.06, and I get 1.05 moles of N2H4. Okay, and the last one is down here at the bottom, so I'm going to erase everything, and I'm doing D. So the molar mass, I have aluminum, which is 2 times the 26.98, is 53.96. I have sulfur. Alright, so because of the parentheses, I have to do the one that's understood to be here times the 3. So I have 3 times the 32.06 gives me 96.18. Oxygen, there's 4 of them, so 4 times the 3 gives me 12. So I have 12 oxygens times the 16 gives me 192. So that adds up to be 342.14, and that's in grams per mole. And I'm just going to go down here. So 227 divided by the 342.14 gives me 0.663 moles. And I just like to always put the compound 2, aluminum sulfate. So this is an ionic compound because this is a metal. Aluminum is a main group metal, so therefore it's aluminum. And this is a polyatomic ion, which is sulfate, S-U-L-F-A-T-E-E, because the sulfur is off the 7, okay? So the 4 oxygens make ATE, all right? And so this will be the end of part 2 of this